Well, aloha and warm welcomes to Kapiʻolani Community College's STEM SOEST Pāʻina. My name is Jonathan Wepe, and I'll be moderating the event today. First, I'd like to take a moment to thank our host, the Kapiʻolani Community College STEM program, as well as our sponsor, the National Science Foundation, and the GeoPath Impacts Grant. GeoPath is funded by the NSF to advance our initiative and goals of producing a well-trained academic and career workforce that can persist in tackling some of the most complex ocean and earth science problems we face in Hawaii and the world. I'd also like to thank SOEST, the School of Ocean and Earth Science and Technology, for their hard work and efforts to help us bring more students such as yourselves into these exciting fields. Today, we're happy to host our guest speakers, Heather Saito, Director of Academic Advising at UH Mānoa, SOEST. Lisa Irizarry, STEM Counselor at Kapiʻolani Community College. Lisa will be co-presenting with Heather Takamatsu, STEM Counselor at Leeward Community College. Don Viviani, Oceanography Instructor at Leeward Community College. He'll be co-presenting with Jacob Tyler, STEM Instructor at Kapiʻolani Community College. We also have Dr. Mackenzie Manning, Associate Professor in Biology and Marine Biology at Kapiʻolani Community College. Dr. Rosie Allegado, Associate Professor of Oceanography in the Sea Grant College Program, as well as Dr. Garrett Apuzanito, Professor at the Department of Earth Science, UH Mānoa, SOEST. And with our closing statement, we're accompanied by Dr. John Rand, Professor at Kapiʻolani Community College and Principal Investigator for our GeoPath Impacts Grant. We're very excited to have you all here to share the insights and the resources that our speakers have for you today. Our hope is to give you an idea of the various exciting fields you can pursue within SOEST and show you the importance of studying ocean and earth sciences due to the impacts they have on our everyday society. We also want to give you the information you need to potentially get on the right path to lead you directly to your field of interest, the resources available to you and to grow within your academic career, and a glimpse into what type of careers and jobs you can potentially expect upon graduating with a degree and with a major in sciences such as geoscience, earth science, ocean sciences, or atmospheric sciences. We think this is a great starting point for information and resources to get a clear picture as you prepare to move forward in your career. Mahalo for joining us. We hope you take something from this. So to start, we'd like to invite Heather Saito, Director of Academic Advising at SOEST, to open up the event with her presentation on what is SOEST.
Welcome, everybody. We've got a really good turnout this afternoon. My name is Heather Saito. I am a part of Student Academic Services in SOEST, which basically means I do the advising for students in SOEST. And if you come to UH, every school or college has an advising department within their school or college, so you want to connect with that advisor. So why should you choose SOEST? You already know we've got a lot of great research going on in SOEST, but we have strong academics and we are small in size but mighty because we have about 150 students. And so, as you know, you're at the community colleges and you've got that small feel where you get to know your advisors and your instructors. And we'd like to continue that on in SOEST. And so those are several reasons why you should pick SOEST for your major. A couple of facts about SOEST. We were established back in 1998. We are the research arm of the university. We have 3 undergraduate departments, which is Department of Atmospheric Sciences, Earth Sciences, and Global Environmental Science. It's actually Department of Oceanography, and underneath that is our Global Environmental Science degree. And then we have 5 graduate departments, the 3 that I've already mentioned, along with marine biology, as well as ocean resources and engineering. And we have what's called organized research units, and you may have heard of some of them, such as HIMB, the Hawaii Institute of Marine Biology, HIGP, Hawaii Institute of Geophysics and Planetology, HNEI, Hawaii National Energy Institute, as well as JIMAR, CMOR, Sea Grant. They might be other research units that you've heard of or are familiar with. So our students are interested in a variety of topics, which is a good thing and a difficult thing because there are so many different avenues and paths that you can take in order to achieve your dream career. And so I encourage you, if you are interested in any of the following that you see or ones that aren't on here, to talk more to us today about what your interests are and how we can help you pursue your dream career. So let me tell you a little bit about our majors. We have 4 different degrees that you can get at UH. The first is a BS in Atmospheric Sciences, a BA in Environmental Earth Science, a BS in Earth Sciences, and a BS in Global Environmental Science. And as you can see, you see a lot of Earth and Science and Environment in these titles. So it's really important for you to clarify what the differences are between these degrees. And so if you go ahead and search UH Mānoa program sheets, it will take you to a website that will show you all the different degrees at UH, and you'll be able to compare the different requirements. Additionally, I want to tell you about our 5-year combined bachelor's and master's degrees. So generally, students take around 4 years to get an undergraduate bachelor's degree. And if they pursue a master's degree, it can be 2 years or more. We found a way to combine those 2 degrees into 1 degree that occurs within 5 years. So if you're interested in any of the topics that you see on the screen, please talk to me more about that. So what do we do to help our SOEST students have a seamless transition from the community college to UH? Well, every student's going to have a college and major advisor. My job is to serve as your college advisor. And my job is to help you with your gen ed and your focus requirements, any university requirements, a seamless transition to UH, as well as informing you about campus resources. Your major advisor is going to help you out with all things major related. What can you do with a major? What careers can you pursue? And what kind of research and internships you can participate in? And that's something we're really big on. We get that grades in school are important, but we also want you to participate in activities outside of class. And so that's the kind of things that we'll talk about when you come in for mandatory advising every semester. What other things can you be involved in? What research is out there? What are you interested in doing? And of course, what career do you want to pursue once you graduate? Additionally, we realize that math and science can be hard. And so we have our own dedicated SOEST tutor to help students with chemistry, calculus, and physics. This school year especially, we realized that it's hard for students to kind of get together and socialize. So we've established weekly tutoring groups for students enrolled in pre-calculus and calculus. And this has really helped to keep students connected because like I mentioned, our small size allows for students to really get to know each other. You won't just be a name or an ID number. I'll get to know your face, your interests, and what you want to do with your degree. And so when we are back in person, each department has its own student lounge, which is a real plus because you already have a place that you can hang out, meet other students, as well as having a place to study. The library is a great place to study and you should have more than one place. But if you already have the student lounge, that's some place that you already know you can go to in between classes and when you have breaks. And the lounge serves as a really good social place too. Our upperclassmen are there hanging out, socializing, and you can rely on them to network and find out what kind of opportunities and programs they've participated in. And they know that they've had great mentors and friends when they started on the program. So they're more than willing to give back to our new students and kind of show them the ropes and what's going on. Additionally, we have OS 100, the college experience, which all students will take. And we ideally like you to take this course your first semester here, but we get that it doesn't always fit into your schedule. So in this class, we talk a lot about career planning, resume, our personality, our strengths, and how to look good on paper when it's time to apply for different opportunities. And so if you take it in your first semester, if you can, or when you get here, it'll be a class that you'll find very useful. So like I was mentioning, we really want you to be involved in school. There are field trips, labs, employment, internships, research, and clubs that you can participate. Later on, you'll hear a little bit more about Miley Mentoring. If you are looking for employment on campus, that's a great way to be connected to UH, as well as potentially starting off some research. I've had students who have started in the lab washing lab materials or prepping samples, and that has led to research and opportunities. Also, all students are a part of SOEST Club. This school year, we've done a lot with trivia nights, resume workshops, Zoom etiquette, and we're doing a couple of workshops coming up on grad school, as well as how to make personal development plans. So we've got a lot going on within SOEST. So if anything that I've talked to you about today seems mildly interesting, we want you to be a part of SOEST. And you'll hear a lot more about our programs in detail coming up. So what's next? Next steps. Take calculus, chemistry, physics, and biology. Your advisors will be able to tell you how many semesters of these subjects that you need. Get involved with research and other opportunities. There's a ton of great stuff going on at your community colleges right now. Meet with your advisors regularly. Share your academic and career goals with us, because if we know what you're interested in, we can tell you about different programs and opportunities that are available to you. And if you have more than 2 semesters at the community colleges, consider speaking with a KaiEA transfer specialist. They are our experts in getting students from the community college to UH. So here is my contact information. I'll also throw it in the chat. You're more than welcome to email or call me at any time. I will answer the phone if you call that number, or I'll return your call for sure.
Good. Great presentation. Thank you, Heather. We appreciate it. We have a couple minutes for questions, if anybody has any for Heather right now. And we're also, just before we get started with that, we'll also have a Q&A section towards the end of the event. So if anybody doesn't get to ask their questions now, we'll get an opportunity later again. So to kind of address anybody that they wish. So yeah, if you guys have any questions, please go ahead. And we have a couple of minutes before we move on to the next speaker. So feel free.
I just threw my contact information in the chat, so hopefully you got that, or I can throw it in there. And there was a question about, do students find jobs here? Can you be a little more specific? Are we talking student jobs or jobs once you graduate? And I would say yes to both. We have listservs, thanks Scott, that we advertise job opportunities. So we're really well connected to our alumni, and they are very kind to send us information about job opportunities at their places of employment, or if they hear of open positions. So if you are interested in the band, thank you for a bachelor's and master's degree combined. Please start talking to us about that, because usually you start that your junior year, and you need to apply for different programs, but they may be sometimes some occasional prerequisite coursework that you need. So for instance, for our public health and GES degree, you need to take the intro public health course. Same for our urban planning track. There's an intro planning course that you may need to take. So if that's something you're interested in, let's start talking about it now. And you don't have to commit until you get to UH and you apply to those programs. And that'll start your senior year. So great question.
And Scott provided some great information too. Their starting salaries at geotechnical/environmental companies in town here in Hawaii are actually around $45,000, $50,000. Thank you, Scott, for that. We have another one from Ibrahim. What are the programs associated with climate change?
All of them, because they all deal with the different things that are happening, whether it's the air, the land, or the sea. They're all dealing with climate change. So it depends on what your interest area is in trying to narrow that down. Because we are all part of the same school, there's a lot of crossover. So you have the opportunity sometimes to take electives from other disciplines and areas within SOEST. And we encourage that because we want you to have a strong foundation in all of the areas. So great question.
Great. Anybody else? Thank you, Garrett. Climate change will be a driver for healthy, grown, and geosciences careers. Okay. How about cave science? Okay.
I'm so happy we've got some earth science professors on the Zoom today. I'm gonna let them take that question.
Okay, great. Well, we could wait for Garrett's talk then, if you want to save that question, Shek. Fantastic. Anybody else, or is SOEST the class?
Maybe I'll just jump in.
Oh, I'm sorry, go ahead.
There's no specialists here in the Department of Earth Sciences in cave science, but if you want to learn about cave science, there are lots of people here that are happy to help advise you and explore the topic for sure, in a research project or whatnot.
And Scott added, certainly there are people who study lava tubes. Elsewhere, UH are biologists and entomologists who study the creatures and plants that live there. Great info.
And Zach, I think this will probably be my last question. You had a question about OEST 100. That's a class you'll want to take your first semester when you come over to UH. And if it fits, great, but I also understand that it doesn't always fit in people's schedules. So just take it when it fits and you can have a chance to, if it works, whether it's your first semester or your last semester at UH.
Great, okay. I'll go ahead, so we'll go ahead and move on now with our talk from Lisa Rizari and Heather Takamatsu, the STEM counselors at KCC and LCC respectively. So we'll go ahead and open the floor to them. I'm sure they have some additional information about the pathways from the community colleges to UH Mānoa SOEST. So if you will, ladies, take it away.
Thanks, Jonathan. Welcome to all of you to the Pāʻina. Thanks for joining all of us. Lisa and I will be presenting on UHCC's to SOEST. I'm Heather Takamatsu. I'm a STEM counselor at Leeward Community College. And my partner today is Lisa Yarzari, who is a counselor at Kapiʻolani Community College with the Maeda Canver Center for Career Exploration, Transfer, and Graduation. And we're proud to represent the community colleges today. And what we're going to be covering will be intro to the CCs. We're going to share our degrees and how it aligns to SOEST, suggest some classes to take at the community colleges, and then also talk about the Ka'i'i program that Heather mentioned earlier. So we have 7 community colleges scattered across our state. 4 are on Oahu, and then we have at least one in each county as well. It's a great place to start. And why is that? Because we have an Associate of Science in Natural Science, Physical Sciences. And that degree is the one that aligns the best with the SOEST curriculum. So through that degree, you're able to complete about 2 years of coursework prior to your transfer. It is available at all of the community colleges as well. And then also the lower division, so the 2 years of coursework will all be lower division classes. So the 100 and 200 level classes is what you can get done. And Lisa will go into a little bit more detail about what type of courses you can take before transferring. Some of the benefits of starting at a CC, as you can see, there are more of us, so it's probably closer to home for some of you. The class sizes are usually smaller for the general education and the intro classes, and it could be economically more feasible for some of you to start at the CCs prior to your transfer.
Mahalo, Heather. Okay, all of the community colleges have counselors and instructional faculty who can help you to select courses on a path to the SOEST degree programs at UH Mānoa. And our goal is really for what you take at the community colleges to move smoothly over to UH Mānoa and count towards your 4-year transfer major to save you time and money. So this is just a sampling of coursework that you can take at the community colleges. Your 100, 200 level, lower division general education courses, as Heather mentioned, we offer at the community colleges, like your English 100, for example. I highlighted a few courses here. I'm not sure if some of you may be in our liberal arts program, kind of exploring pathways to the geosciences. If you are, a great introductory course is OEST 101, Natural Hazards, really for all students. This is a course that will be offered in the fall 2021 at both Kapiʻolani Community College and Leeward Community College. And natural hazards are things like earthquakes and hurricanes and tsunamis and floods, and how these natural hazards can impact us and human civilization. So you'll hear more about this fascinating course from our faculty who will be teaching the course in the fall a little bit later on. And then if you might have an interest in the earth sciences, perhaps Earth 103, we have an accompanying lab, Geology of the Hawaiian Islands, if you're interested in learning more about how the Hawaiian Islands were formed, volcanoes, landforms, rocks and minerals, that might be a great introductory course. And then Ocean 201, Science of the Sea. So a survey of the science of oceanography, sort of the origin of oceans, the causes and effects of currents, waves, and tides. If you're interested in marine ecology, this might be a course that interests you. And all of these courses have the DP, Diversification Physical Science. The labs have the DY Science Lab designations, so they can count towards the liberal arts degree in that respect. They might also count as liberal arts electives, so you should work with your counselor to determine how these courses would fit into your academic plan. But these are great introductory courses to explore. Mackenzie Manning, our amazing biology and marine biology faculty member at Kapiʻolani Community College, will be talking a bit later about the Marine Option Program, which is offered at all 10 University of Hawaiʻi campuses. So that's another great way to kind of explore the geosciences. You'll also complete the foundational science courses, mathematics courses, and you'll be taking math through calculus. So we offer all of these courses in addition to research opportunities and mentoring opportunities with our faculty at the community colleges. All of the community college campuses offer the Kaiʻeʻe program, which helps students transfer smoothly from the community colleges to UH Mānoa. It's a dual admission, dual enrollment program. So essentially, you are admitted into UH Mānoa. Manoa is your secondary campus while you're still a community college student, which opens up the door to begin to take classes at both the community college and UH Mānoa. This program is free and easy to join and has a lot of benefits. But what I want to leave you with is all the coursework and credits that you earn at the community colleges would give you sort of that kind of priority registration when you're ready to transfer to UH Mānoa, in that you would be able to register with all the continuing Mānoa students in that transfer semester. So we just want to leave you with, there is a path from the UH community colleges to Mānoa SOEST to geosciences careers. So you would enter STEM at the UH community colleges, complete the AS&S physical sciences, transfer to UH Mānoa SOEST, and then graduate with a bachelor's degree. If you have any questions or want to learn more, please feel free to email Heather and I. Our contact information is there, or reach out to your counselor at your community college. Mahalo.
Thank you.
Fantastic. Thank you, Heather and Lisa. That was great. Does anybody have any questions for Heather or Lisa? Anything particularly that you're interested in knowing more about? We have a couple minutes here before our next speakers. Okay, great. Well, we'll have another opportunity towards the end again if anything occurs to anybody for Lisa and Heather. They're great resources for anybody that'll be attending KCC or LCC in the future. So they're definitely the folks to speak to. So we'll go ahead and we'll move on. We'll move on with our next speakers. We have Don Viviani, professor of, oceanography instructor at LCC. And we have Jacob Tyler, STEM instructor over at Kapiʻolani Community College. And they're going to share a talk with us as well. So we'll go ahead and hand it over to them.
Great, thank you guys. So I think, in some ways, today is a really apt day to talk about the study of the Earth, and in particular talk natural hazards. When you think about the fact that 10 years ago was the really big Tohoku earthquake and tsunami in Japan that had such a major effect on that country and worldwide, really. When you think about the fact that many people in Honolulu lost power last night, there was a dam overtopped. There were towns here on the islands that had to be evacuated. I myself spent a lot of this morning digging out a flooded apartment, and I know that I'm not the only person in this chat who has spent time over the last couple of days dealing with flooding. So in some ways, it's sort of a really apt day to talk about natural hazards. But in another way, that's part of the price of living on Earth. We as humans perpetually live sort of at the edge of destruction. We are always at the mercy of different types of events that happen on the planet. And the question is not, can we stop these things? The question is, do we understand them and are we prepared to deal with them? And so that takes us to the class Natural Hazards. Next slide, please.
Yeah, so we wanted to talk a little bit today about this this OS 101 Natural Hazards class that Lisa had introduced there a little bit. And it's an introduction to the study of geosciences through a lens of looking at the hazards involved with just living on it. And we have this quote here by this philosopher Will Durant. Says, civilization exists by geological consent, subject to change without notice, which really kind of hits on our presentation today, because actually we had a kind of a different presentation, and we changed it based on just the events of the last 2 days to start off with floods, because it's such a dynamic earth that we live on, and there's it's really a dynamic class because of the the dynamics of the earth. So we want to talk about this a little bit. A quick little introduction. I have myself over here, the picture. This is actually a pre-COVID picture with me and my son over there. I have 2 children now, but I'm an instructor over at Kapiʻolani Community College. My contact information here, it's best to email me, but I think all the contact information is going to go out later on as well.
And I upstaged Jacob by giving myself 2 pictures. One of them is from some of my time at sea. I have over a year of ship time. Here I am waiting to try to recover an array that's floating in the ocean. And on the right, I'm shown with my toddler teaching class from home during the pandemic, dressed as a pirate for reasons. So anyway, so feel free to get in touch with either of us if you're interested. Next slide, please. But sort of pursuing this theme that we live on this planet where we have these things that can and do go wrong. This is something that's in the news recently. This is the volcano ʻIna, which is on the island of Sicily, right above the city of Catania. Italy, as a country, has a number of active volcanoes that are near major centers of population, including Naples, the city my grandparents came from. And the point here is not that this is an unusual thing, right? We know that volcanoes erupt on the Big Island. We know that volcanoes erupt in many other places, including Iceland and many other places. And understanding what is happening, why this happens, and how we can do that is crucial for living on the Earth. So next slide, please. So why might you want to study earth science, right? Whether or not you intend to go into earth science. Well, let's take, for example, the experience of BJ Penn, who growing up in Hilo, right, said that tsunamis are big news, right? You have to get ready to escape a tsunami living in Hilo. Because no matter where you live on Earth, you are likely to be at risk of at least one type of natural disaster, whether that's a volcano, whether that is a flood, whether that's a hurricane or a typhoon or an earthquake, right? And the question is not, are these things going to happen? Because they are happening somewhere all the time. The question is, how do we respond? Do we, run around like headless chickens in a panic? Or do we have a plan to respond because we understand what's going on and we prepare from that place of understanding, right? So the idea behind this class is that we are sort of giving a baseline of what these disaster risks are, why they happen, and also how can we mitigate them. And if you think about different professions, different jobs that you might have, how important as, say, a farmer or somebody involved in agriculture is understanding what's happening with rainfall, what's happening with flooding, right? If you're a fisherman, you might need to understand ocean conditions, hurricanes, engineers, community leaders, business people, politicians. If you're planning a city, if you're planning a community, if you're trying to figure out what kinds of buildings are going to go where, you need to understand what the risks are from natural hazards. Or doctors might need to understand what potential risks are for example, pandemics, which may be affected by climate change. So we can't stop these events, but we can prepare for them so that they are less disastrous. We want to look at the ways that we can understand earth science and how we can look at that through sort of a lens of the Earth as a system, because the Earth is in fact a system. So next slide, please. Shown here are 2 volcanoes. Oops. And these volcanoes look very different. On the left, you see a typical shield volcano like we have on the Big Island that erupts in one way with this sort of spread of flowing lava. And on the right, we see a stratovolcano. This is Mount St. Helens when it erupted in 1980, spreading ash across much of the western continental United States. And these are 2 totally different types of volcanoes. And if your city or town is near a volcano, it's sort of important for you to understand which type of volcano you're near, because that's going to have an effect on what the volcano might do. Next slide, please. So as I said, there are natural disasters happening throughout the world right now. There is a polar vortex that's affecting weather patterns across much of the country. There are power outages in Texas. There are earthquakes and volcanoes in more countries than I can list on this slide, everywhere from Greece to Guatemala to the Philippines. And there have been major wildfires, right? In California is dealing with these right now. People have been locked in their houses in much of Northern California because of not just the pandemic, also the wildfires making the air too bad to breathe, but also out in Waianae, we're having these major wildfires, right? And the question is climate change affecting this? Are we getting warmer and drier? And is that causing there to be a greater risk of wildfires? Next slide, please. So over the course of Hawaii, over the course of the recent history of Hawaii, we've seen a number of different types of natural disasters that have had an effect, right? From earthquakes to tsunamis, to hurricanes, to the eruption of volcanoes, all of which have impacts on the people who live here. And these disasters are going to continue in the future. And we have some ongoing processes like shoreline erosion and climate change that may make them worse, that we need to understand in order to sort of take into account what's going to happen. Next slide, please.
So we wanted to, that's kind of, Don mentioned, like the way that we look at this class is really, we look at, the science behind, explaining these events and how they happen, but also how they affect, society, the societal impact on them as well. And so we look at, we have all these topics here. We cover earthquakes, tsunamis, climate change is something that runs through the entire course. As Heather was saying earlier, it's in everything, right? Landslides, beach erosion, tornadoes. And the way we look at these is we, in this class, is that, we look at the explanations of the kind of the physics behind what drives these events. And then we also look at how our society responds to them and how it's actually changed in our society as well. We also kind of, you look at some things like, like a hurricane, for example, how does it form, et cetera. But, some more, I guess, prudent information for the general public, is what's more dangerous, a hurricane passing through Oahu and Kauai or one that passes through Oahu and Maui, right? So kind of look at these very kind of important things for just, living in a place where hurricanes occur. So I just wanted to touch base on kind of a couple, I guess, examples of some of the topics that we cover, like earthquakes for one, just to kind of show you how we go into this stuff in this class. We go over what causes the earthquakes, right? How do we measure them? We cover, different plate boundaries and whatnot. How do we measure them? Cover P waves and S waves, Rayleigh waves, Love waves, etc. How often they occur, and also, we cover more than what causes the earthquakes is really what we're mostly interested in, especially in this class, is what causes damage from earthquakes, right? So it's not just the magnitude of it, it's the depth of it, is what kind of materials are the buildings made out of, but what sort of land are they on? Are they bedrock, loose soil, etc. So we cover kind of things like that. We actually had an earthquake yesterday, right? 4.2 yesterday on Big Island, which if you live on Big Island, they're fairly common, right? You know about them. We don't feel them as often on Oahu, but they're actually really common in Hawaii. If you look at this chart here, we get a 3 to 3.9 magnitude earthquake every 3.5 days. That's our average time between the earthquakes there. And if you look at what happened yesterday, between a 4 and a 4.9, that's happening like once a month on the Big Island. Something between like a 5, 5.5, that's something that we can feel on Oahu. So it may not, rattle us on Oahu, but every about 1.5 years, we could feel something on Oahu. And if you look at kind of the recurrence interval for a 7+, that's every 56 years. So it's a pretty good chance that you're going to feel like a pretty substantial earthquake sometime in your life here. We'll also, we talk about how we react to these events, but it's also important to talk about, in some cases, how we can not cause them. So actually, kind of a fun little fact that I like to throw out is in 2015, Oklahoma, which is not really an earthquake place, it's not where you think of when you have earthquakes, actually had 900 plus, more than 900 magnitude 3+ earthquakes in Oklahoma. And they found out that this was actually due to injecting kind of wastewater from fracking into some old faults there. And so you need to have some knowledge of this so we don't, create earthquakes there. Tsunamis, that's another big one in Hawaii and BJ Penn there. We cover obviously the mechanics of the tsunamis, how they're different than wind-caused waves. They're incredibly long, fast, 500-mile-an-hour moving waves. Usually people think of them as a really big wave, but it's really more like a long river that's coming in. How does our warning system work? We kind of take a look at that as well. We have these dart buoys out in the ocean. How accurate is it? What sort of safety things might you need to take if a locally generated tsunami happens? Don mentioned earlier, this is actually the 10-year anniversary of the Tohoku earthquake and tsunami to the day. So, we talk about some specific events, global events as well as local events here. Coastal erosion, another one that was brought up here. The majority of the beaches on Oahu are chronically eroding. I think we've lost like 25% of our beaches in the last century. And it's a complex topic. There's a lot, I think you're gonna hear more about it later, but there's a lot of things that can take into consideration: sea level rise, worsening storms, etc. But we also talk about, can we mitigate some of this erosion? And actually, what happens if we do? If we build up some seawalls and other barriers, that's might be really nice in front of our house, but what does it do to our neighbor's house, kind of type thing. So some of these things that we address that are very relevant to living in Hawaii. We're trying to kind of drive home here is that it's, if you have just the slightest inkling in earth sciences or disasters, you should take this class, because it's very relevant to just living here.
Right. And so the last sort of thing that we'll touch on here is climate change. And the question is, the climate is changing. We know it's changing. We know it's us. And how does that affect these other natural disasters that are just part of the cost of living on Earth, right? How do changing climates affect weather patterns? Are we going to see warmer weather with not more rain, but more intense bursts of rain, like, I don't know, the last couple of days, right? That's going to have a big effect on the way that we live and work and design our communities. What is that going to do to the ocean, right? What is happening to the ocean? It's rising, it's warming. What effect is that going to have on the amount of oxygen that's available for fish? What effect does changing the chemistry of the ocean have on the coral reefs that play such an important part in the nearshore coastal system of these islands? So it's really important that we think about these different natural disasters in not just in isolation, but also in terms of how they interact with each other. And a lot of times when I talk about climate change in my oceanography class, I make the point that this is the issue that will dominate the lives of the students that are taking the class. And students say, what can we do about them? And I think one of the things that we can do about them is we can talk about these issues. And to talk about them, you want to talk about them from a place of knowledge. And so I think that's one of the other nice things about this course is that we're giving you the knowledge, we're giving students the knowledge to sort of figure out these things for themselves and then be able to talk about them. Next slide.
And really to be contributing members of the community as well. Don mentioned earlier all the different fields that geosciences play into. Another one there is, politics, right? We are elected officials that are out right now talking to geoscientists, like, what do we do? How can we mitigate the results of these floods, right? Or the effects of these floods? It plays into all these things as well. So another thing that, students takeaways, if you want to know what you kind of immediately get from this class, you understand how to react when disasters happen, kind of a fundamental understanding of our environment and how it relates into other career paths. So even if maybe you'll find out you take this class, you want to go into geoscience, maybe not, maybe it feeds into somewhere else. You get a basic understanding of geology, oceanography, meteorology, earth sciences, familiarity of scientific language. So this kind of plays into getting a physical science diversification. So at least something that you get, kind of right away on your transcript, you get that DP, and you have that to, at a minimum, you're going to have that, right? So I wanted to end it here with kind of a little advertisement for a student undergraduate research fair that we have at Kapiʻolani. I think Leeward has one as well, and I think you can get that contact or that information later on. But I have an experimental version of this course running right now, OEST 197, and some of my students will be presenting at this undergraduate research fair on a natural disaster that impacted their life in some way, kind of the science behind that disaster. So there's some really good ideas coming in from my students, and I think it's gonna be really exciting to see that. So if you wanna kind of see kind of more from a student perspective, taking this class, come to this undergraduate research fair that we have in the first week of May there and check it out a little bit.
Great, thank you, Don and Jacob. That was great, that was fantastic. I think we're running a little bit short on time, so if anybody, we might be able to get 1 or 2 questions in if somebody has one for Jacob or Don particularly. Nobody? Okay, we have some great resources in the chat if anybody wants to take a look. Troy Terrazono has a question. OS 100 will be available in the fall at Leeward?
Yes. Yep, we'll be teaching natural hazards in the fall at Leeward. I'm really excited to teach it. I'm not guaranteeing that I'm going to dress up like a pirate every day.
So no pirate suits guaranteed. Sorry, guys. Fantastic. So we'll have more Q&A at the end. So we're just going to try to move on here because we want to stay on time. So next up, we're going to have Dr. Mackenzie Manning. She's an associate professor at KCC in biology and marine biology. And she's going to share with us some information about her marine options program. We're really excited to have her here. So Mackenzie, if you want to go ahead and take it away.
Hi, my name is Mackenzie Manning, and I'm a biology and marine biology professor at Kapiʻolani Community College, and I'm also the Marine Option Program Coordinator here. And today I'm going to give you a brief overview about our Marine Option Program Academic Subject Certificate. So the Marine Option Program allows you to really learn hands-on about Hawaii's marine environment through experiential education out in the field, lots of different field trips to both research facilities and natural laboratories. And then of course you get the opportunity to conduct some research through various courses that you take and even our MOP skill project. The Marine Option Program's mission is to enrich the quality of life of its students and the community by increasing ocean awareness, understanding, and appreciation through experiential marine related education. So this experiential emphasis is what the folks that have created MOP, which is almost 50 years in the making within the UH system, thought was the best way to get students to learn about the marine environment by immersing them in the marine environment and giving them access to learn hands-on in our marine environments. The KCC Marine Option Program's Academic Subject Certificate is a 12-credit certificate. So 4 of those credits are some required coursework, 6 of them are marine-related electives, and then there's 2 credits of independent study, and that helps students design and conduct what's called the MOP skill project. So this is kind of the culminating event before you get your subject certificate. And you work with me and potentially another mentor to design and conduct any project of interest related to the marine environment. So you can really focus in on something you're passionate about. You can pursue a volunteer or internship opportunity, or perhaps even address a research question of interest. So the MOP skill project can be anything that you want it to be, as long as it's marine related, whether it be field or lab, computer-based modeling. And every April, all 10 campus Marine Option programs get together, their students present at the MOP Symposium, and you get a certificate, and you can present either a poster or give a scientific talk. So it gives you great networking capability or options and opportunities to just get out there in the marine field here in Hawaii and meet some different people and showcase your skills that you've learned through the certificate. So the benefits include the academic subject certificate from KCC, as well as a Board of Regents Regents certificate that's system-wide. So this means it posts on your transcript. Your skill project title will also post on your transcript. And this is also something you can highlight on a CV or resume when you're applying to jobs or to other institutions. And it kind of shows employers or other folks that you have a specialty in the marine science and that you have the discipline that it takes to have completed your own independent marine related project. So this increases success, hopefully, in obtaining employment in any occupation where ocean awareness is applicable, or for further study at a higher learning institution. I should also mention that the Marine Option Program is not just specifically for marine bio students. It's actually available to students in any major. So I've had hospitality and tourism students. I've had art students as well. So anybody can join MOP and really learn more and get excited about the ocean. So to start your path on becoming tomorrow's ocean leader, you can contact me. My email's here. I also have a KCC MOP website, and I'll put this in the chat as well. And one of your required credits is the Ocean 101 MOP seminar course, which I teach every fall. It's a 1-credit course. This fall, it'll be run on Thursdays from 4 to 5. It's going to be a synchronous online course, so we'll meet on Zoom. And there's the CRN number if you'd like to register or write that down. I'll also put that in the chat. And with that, I will take any questions.
Fantastic. Thanks, Mackenzie.
No problem.
Scott said a great thing. He said it changed MOP changed his brother's life. He said he's a very successful wildlife biologist now. So that's amazing.
Nice.
You have a couple questions here. You have one from Monica. Is there a diving certificate that comes with the MOP?
No, but I will put you in touch with the dive safety office up at UH and can connect you on how to get dive training, especially scientific diver training up there. And they also run a variety of courses that are dive and research dive related.
Great. And then Lee said, are there any scuba related courses or activities? So I guess that falls under the same umbrella. If so, does having any experience diving prove beneficial?
Yeah, it does actually. We, under the UH auspices, we don't do any diving, but we can go out and partner with other nonprofits to do some cleanup dives, which we've done so in the past.
Great. Fantastic. We have another one from John. Can MOP be focused on surf and ocean waves?
Oh, it sure can. About 2 years ago, we had 2 students present their MOP skill project comparing surf forecasts, Surfline, SNN, and then Pat Caldwell at NOAA before he retired. So that was a really exciting project. Yeah, anything you're interested in, anything you're passionate about.
Great, great. Seems we have some aspiring scientific divers, so I think MOP is a good source for them.
Yeah.
Awesome. So we're going to go ahead and move on with Dr. Rosie Allegado. She's associate professor of oceanography and the Sea Grant College program at UH Mānoa SOEST. We're really excited to have her here, and she's going to share with you some great resources over at UHM if you particularly decide to go ahead and take up one of these fields. So Rosie, thank you for being here. Go ahead.
Aloha mai kakou, everybody. Thank you for the opportunity to share this work. First, what I want to say is that while SOEST Maile Mentoring Bridge Program is centered at UH Mānoa, that we actually extend into the community colleges, and the Bridge Program is for students who are looking to transition from the community college to UH Mānoa. I also want to just put up front our contact information, which is maile@soest.hawaii.edu. You can also follow us on Instagram at SOEST_Maile Mentoring. And this program, I am in no way, today I'm just representing the program, but I would say the majority of the work is carried out by our alaka'i, who are both graduate students, Pu'i Keli'i Puleole and Huaka Thomas. This work is supported by the NSF as well as SOEST. Okay, for some reason, oh, there we go. So we have a couple questions about what can we do with a SOEST degree, and I kind of threw this slide back in there. And why should I go to university? Should I study science? The answer is absolutely yes. Here are some numbers for how much you can make and how, if you go into the STEM fields and get your bachelor's degree and then your master's and doctorate, particularly in the STEM fields, the pay is above average, and undergraduate is usually, and graduate school is usually free because it's paid for either by graduate research assistantships or TAships. So there is a significant income difference between getting a STEM degree and not. But you should also do it to get a job that you love to do. And these pictures show people from SOEST, people who have been part of the Maile Mentoring Bridge program. And they're all out in the field. I think as Heather Sento brought up, in SOEST, we really, really emphasize you getting out into the field, out into the community and experiencing ocean, earth, sky, atmosphere, everything. And it's really important that you discover your passion so that you can get the job that you love. And the way that we do that, right? Because the big question is, how do you do that? We really facilitate that through identifying people at the community college level who are really interested in these kinds of subjects and connecting them with people who are already at Manoa. So our mission is to raise exposure and awareness about SOEST programs. In particular, our goal is to attract Kama'aina and other underrepresented undergraduates into SOEST degree programs, and then to help them thrive through individualized mentoring as well as peer support. This is an image from one of our last STEM Pāʻina programs where we brought together students who are both at the community colleges as well as at UH Mānoa, just to get together and eat and talk story and have fun. We're really motivated by, and I have to give huge credit to Auntie Kapiʻolani Noa, who used to run the STEM Center at Kapiʻolani Community College. We really developed this program in partnership with her, and she gave us our name, the Maile Mentoring Bridge Program. And so our long-term goal is to develop and nurture students who have an ancestral lens to their science integrated within 21st century methodologies. And we do that by valuing our resources, looking how to value and center our own well-being and intergenerational knowledge. We also see that the journey starts at the community college. At the community college, where many of you are at, you gain this model of understanding of how science and university and academia works. Maybe you'll do a summer bridge, participate in peer mentoring at KCC, you'll really solidify your love for STEM, and then you'll try and kind of get more experiences, perhaps during internship or research opportunity. You'll enter into the transfer process, as many of the previous speakers have talked about, and then you'll end up at SOEST. And at SOEST, our goal is to continue to foster those relationships and launch you into a career so you can have really successful outcomes. And we see the Maile Mentoring Program as kind of in the middle of that, identifying people and as a wraparound service from the community college all the way to SOEST and beyond. So to be eligible for the program, you can be a Native Hawaiian or an ethnic minority or a Kama'aina, that's a local student. And the second eligibility is that you have a plan to attend UH Mānoa for either global environmental science or atmospheric sciences, or I'm sorry, this is a little bit of an old slide, earth sciences, also formerly known as geology and or geophysics. But we also recognize that there are other specialties in SOEST that don't have undergraduate majors, and those are ocean and resource engineering. And we have accepted engineering students who have declared that they intend to transfer into the ocean and resource engineering program, because we think it's very important to integrate people into SOEST as early as possible. The third is that you should be an undergraduate somewhere in the UH system. You can be at Mānoa, you could be at KCC, Leeward, Windward, wherever you're at. Honolulu Community College also. What we're expecting from all of our mentees is that you come to us as a self-directed learner. You be ready to contribute to the conversation of what's going on. There's a lot happening to the university in terms of education, to our climate, to our community, right? So not just the conversation we're having right now, but the conversation of society. We want our mentees to begin to think with impact and understand how their science is going to impact the community. We are trying to cultivate quality at every step of the way in everything we do, and to have that supported by our natural resources and our cultural resources. When that happens, what we see is that the transfer experience from community colleges becomes a personal experience. The images that I'm sharing you here are pictures of the end goal. We have our graduates. You can see that they're wearing their kihei and their maile. And I should say the bottom picture, some of you might recognize Auntie Kapiʻolani, who even comes to our graduations as a symbol of how much, you know, we go from that little comfy nest that is community college to SOEST. And as Heather said, our school is small and we have that opportunity to know every student who is transferring and to really make it a personal experience. And if you're wondering what they're doing up above, as part of the graduation experience, our Maile mentees make their own kihei and they carve on bamboo, which is called ohe kapala, what represents their science research. And so when they wear these at graduation, they're saying, this is the science research that I participated in. So here's some of the benefits of becoming a mentee. The first is you get support and advice because, as I said, we pair students, whether or not they're at the community college or already at Manoa, with a graduate student. We've also had really interested staff and postdoctoral fellows who want to mentor students. And so these are just some of the images, past and present, of our mentees and our students. A second benefit of being a mentee is you get free lunches with your mentor. Again, this was very much in the pre-COVID era. We fund you to have lunch with your mentor and just hang out. And it fosters relationship building. And we encourage the mentor to do two things. One, have lunch at the community college. So the mentor understands what you as a student are going through in the community college experience. And then we also ask that your mentor invite you to Manoa so that you can have a chance to see what it's like at this much bigger campus. And then of course you can go anywhere else. The other is that we have really planned a lot of group events that happen about once a semester or more, often involving food, as you can see. And we also participate in a lot of SOEST related activities like SOEST Open House. You can see that we're also here volunteering at a invasive limu removal. And something new that we recently added right before COVID is Ava Nights. Another benefit of being a Maile mentee is that you get exposed to ocean and earth science research. The main reason why we selected as our mentors graduate students and staff is because they are already in these labs. And by inviting them, we encourage our mentors to invite our students to let them see the real life work of what they're doing. And it even actually has opened up opportunities for our mentees to participate in research cruises as well as lab work. This is often a very much a mechanism by which interested undergrads can find their way into labs. And the fifth is when you kind of get into the Maile hui and on our mailing list, we very much push out opportunities for summer programs, career opportunities, and other internships. So you get to learn about our secret, it's not really secret, but we very much are active in helping our mentees identify additional potential career opportunities. Of course, as we know, we've been in the pandemic, so I just wanted to show you a couple of ways that we've continued to strive to connect with our students. And again, this is completely all work that has been done by our alakai, which is Kuli and Hoaka. So, you know, it was very hard. And we still have been organizing Maile pop-in Zooms. We've been organizing workshops, career workshops. We hosted movie nights. We hosted a mini grad party. And then even over Christmas, because we missed everybody, our alakai got together little Christmas packages and we had a drive-by where our students and our mentors could pick up the goods, and then we actually went home and watched movies all together, synchronously on Netflix party. So we very much, similar to what Heather was saying on trivia nights, we very much tried as best as we could to keep connections. And I don't have pictures of this, but our mentors and mentees even took to writing actual real life letters to one another and sharing their experiences of what they were going through during this pandemic time. And finally, I just want to say that there's many ways to participate in SOEST. There is, of course, the SOEST Maile Mentoring Bridge, which I said is like a wraparound program. We have an ocean summer bridge. Earth Science has a summer bridge. And as you continue on and transfer to Manoa, there are many National Science Foundation research opportunities, as well as the PIPES program. And I know somebody asked at the end about what happens to, can you get a job? This is just a figure for the Maile undergrads. 43% of our students get jobs after their bachelor's degree, 43% go to graduate school, and a smaller percentage go to professional school, like law school or medical school. So with that, we just want to hear from you. So please, again, there's our contact information. There is Ku'i on the top and below is Ho'aka. And this program is very much supported by NSF. We're supported by both the NSF GeoPath as well as the NSF page Halau Olohonua. We've been supported by Sea Grant, the Dean's Office in SOEST, and the UH Mānoa Seed. Thank you.
All right, that's an amazing resource you got there, Rosie. Thank you so much. That was in great detail. Any questions for Rosie? We could take a couple questions if you want to put them in the chat or unmute yourself. And Troy wants to know, he's curious of SOEST grads, do many end up working in jobs in Hawaii?
Okay, listen to the next talk. Right on.
Actually, I'm sorry. Yeah, the agenda here, we have Dr. Garrett Apuzanito next, and he's actually going to speak on careers in geoscience here for us. So he's going to tell us a bit about the workforce and what it looks like, so everybody can get a good idea of what they can expect after graduation. So we'll go ahead and pass it on to you, Garrett.
There, I got to unmute. Well, the quick answer is to that last question is yes. Many SOEST grads end up working in Hawaii. And I'll tell you what I'd like to do today is tell you what sorts of things they do when they work in Hawaii or elsewhere. But first, I'm just like to say, I'm really excited to participate in this event. It's really fun to virtually meet everyone here. I don't get to interact with the community colleges very much, but I'd like to change that. And I look forward to meeting you in person. So yes, so this is me. That's a picture of me. You can tell it's me since you also have a camera picture of me, but I'm in the Department of Earth Sciences. And if I can advance my screen. Okay, that seemed to work. So first of all, what is geosciences? So this is a term that I'm going to use today. Is a very broad term. Geoscience is an interdisciplinary field in which physics, math, chemistry, and biology are all used to study processes of the earth, oceans, and atmosphere. And I guess environmental science could be considered a subfield in geoscience, and that emphasizes interactions with ecosystems and as well as human activity. So some subfields that you may have heard of that are part of the geosciences are volcanology, geophysics, hydrology, climate science, coastal science, geotechnical engineering, geology, oceanography, and atmospheric sciences and meteorology. So what do geoscience professionals do? Well, they work with clients, stakeholders, policymakers, engineers, developers, lawyers, business people, both in industry as well as government agencies. And they support communities and the economies. So you can see that they work with a diverse number of people and professions. They deal, the support they provide are mitigation against natural hazards, identifying natural resources, including water resources, adapting to climate change, including sea level, being able to forecast and inform the public about weather and extreme storm events, for example, preserving property, and certainly assessing sites for future development. So they play an essential role, and I think will play an increasingly essential role in addressing some of the biggest interrelated challenges that we face here in the world, really, and certainly here in Hawaii. One of which is growing populations and the need for natural resources. Another is growing development that exposes more landowners to natural hazards. And then, of course, the big one is climate change and sea level rise. And again, these are interrelated factors that are really big challenges that Hawaii faces. So in terms of natural hazards, you had a really great introduction to that with Jacob and Don. This shows a picture of the eruption at Kilauea in 2018, which inundated or destroyed parts of a neighborhood on the Big Island. If you want to help address issues like that, you can go work for the Hawaiian Volcano Observatory, which is part of the USGS, to help monitor and address hazard mitigation. Another form of natural hazard is landslides. This is an article from the Honolulu Civil Beat that came out a couple years ago, showing how many of properties in the valleys of Oahu are prone to landsliding. And so when landslides happen or endanger property, geotechnical engineers and professionals will come out and assess the integrity of the soil. They'll look at the internal structure, how water flows through the soil, and they'll make plans. They'll work with engineers to make plans for addressing or stabilizing the soil. So you could work for a local company called Masa Fujioka and Associates to help do that. Another one is Yogi Kwan Engineers, for example, both of which employ some of our graduates. In terms of natural resources, water is a huge resource, is a huge challenge here in Hawaii. So we get our water from the ground, and as our population has grown, our water resources are waning, and we need to be able to monitor that and identify the processes that control that and therefore adapt. And so USGS has an office here in Honolulu that employs people that do that. Also, the Hawaii State Department of Health works on water resources. In terms of coastal resources, you saw Jacob and Don talk about beach erosion. One adaptation technique is to replenish the beach. And so the Department of Land and Natural Resources will help address those programs. You could also work for a company like Seafloor Investigations to survey the near seashore to identify potential sites for sand donor sites for restoration. Those are some examples. A big one here in the world, in Hawaii, is energy resources. So a lot of the geoscientists went into petroleum and fossil fuels, but that market is starting to level off and even wane. And I think the long-term trend is to wane. So switching to renewable resources is going to be a big challenge. And you could go work for Hawaiian Electric, who has an ambitious plan for doing that. And there are a number of areas that geoscientists will work with. Whenever land use changes, like for agriculture or wind or even solar plants, geoscientists are needed to address those changes in land use. Hydroelectric energy, we need people who know how water flows on the surface in streams. And then another one that emphasizes geoscience is geothermal, which uses heat from the ground to convert that heat to electricity. This is a big deal. Okay, climate change is another of the big three challenges that I mentioned. And this shows a map produced by Chip Fletcher's group here at UH Mānoa, showing the areas of inundation at a sea level rise of 4 feet. And there's a good chance that'll happen by the end of the century. So this is a huge area of land that's going to see persistent flooding. And with that, lots of development must happen and retrofitting. And this is on the right here is a report that was made by a number of professionals sort of assessing what the likely effects of sea level rise are going to be and what adaptation strategies are needed. And this affects so many people across the state. So whenever you do a new development, you have to assess the site for the type of development. And so what that will involve, for example, is sampling the soil, for example, by drilling, taking those samples and again, measuring the physical properties, looking at, again, how easily water flows through it. You may send it to a lab for testing of the physical properties, the strength of the materials, et cetera. Or you may sample the fluids from what's extracted to test for chemical contamination and so forth to make sure that what you construct there is safe. And so there are a variety of environmental companies, environmental consulting companies that do this work here in Hawaii. from relatively small groups like Geotech to very large companies like Arcadis and AECOM, and these all employ graduates of SOEST. Another big one of climate change is as our climate warms and the ocean temperature warms, that energizes large storms, and it makes them stronger and more persistent. So we need experts who can monitor these storms, inform the public about these storms. If you like computer modeling, you can model how the storms behave. This was a spectacular modeling feat, I thought, by Hurricane Lane, in which it was coming right towards us, but veered to the left. I was really thankful for that. Yeah, that's really important. This is a report by AGI, Geoscience Workforce, showing typical salaries for a range of careers in geoscience. You can see that, so the red here are sort of educators. A lot of our graduates are in the Department of Earth Sciences are in this green area, and then these are the engineers. But you can see they pay well relative to the US occupations on average. And this is our entry level for Department of Earth Science, so they do okay. Okay, so what do geoscience professionals do when they work? They do a variety of things. They work in the field, they work in the lab, whether it's on a computer or in a chemistry lab, for example. You need to learn to speak to your clients, communicate your results, and certainly put together reports for your clients. And geoscientists also collaborate, again, with a variety of professionals from different areas. And last, is you should, ooh, that's my flood warning. Sorry about that. See a natural hazard in real time. So you should consider a career in geoscience for a variety of reasons. Here's a few that are listed. If you like interdisciplinary science, if you're competent in math, physics, and chemistry, but you don't really want to focus on any one of them. You want a diverse work setting with a variety of different professionals. You like to work with teams. You like to think creatively and critically. You're ambitious and work hard. And most of all, you like to solve problems and want to help Hawaii address some of Hawaii's biggest challenges. So I will close there, and thank you for staying to the very end.
Thanks, Garrett. That was fantastic. So if we have any questions for Garrett, actually, you know what? We actually have time for Q&A, so we'll just go ahead and lump Garrett's time for Q&A in there. So the floor is open to anybody that might want to ask any of our panelists any questions or anything of that sort. Please feel free, take the time to do it now. You can throw it in the chat if you have anything to say. Let's see what we can answer here for you guys, if we want to give you guys a clearer picture of maybe the things you can possibly accomplish in SOEST.
I have a question.
Go ahead.
So this is for, like, if you're doing community college first, or because I'm going to UH Mānoa. I'm a senior in high school right now.
This is Rosie. You can definitely come to SOEST straight from high school. And I believe Heather put a resource for prospective students. Maybe if you can re-drop that in, Heather. That's Heather Saito. No, we definitely have programs. Yeah, you can either start, that's right, you can start at community college or at UH Mānoa. There are also a number of programs associated with SOEST for high school students. So there's, well, I don't know if they're active at the moment, but yeah.
So I clicked the prospect one.
Yeah, so if you're interested, the two of us should talk, because I'm going to be your advisor. And if you're coming to UH, I want to make sure that you know everything you need to do to take placement exams, to registering for the right courses. So there's all my information.
Okay, I'll email you.
Great.
I might have to go before the meeting ends. So yeah, I'll email.
Yeah, no worries. You guys will have access to everybody's information. And also we have information. If you guys filled out the forms that we've been putting in the chat in the beginning, the the sign-in forms. We'll have your emails as well, so we can share any kind of resources or anything with you, or everybody's contact information that spoke today, so you guys can reach out to anybody that you might be interested in speaking with in terms of opportunities or advising or anything like that. Abraham has a question. He said, what kind of jobs are available for a computer/electrical engineering student interested in climate change? Maybe Gary.
I can say something about that. So I in my work, I do computer modeling, computer simulation. So if you like to work with computers, there's a huge variety of computer simulations going on throughout earth sciences.
Can I take a stab at it? So computer science is, they're absolutely critical for a lot of oceanography, instrumentation, also creation of models, our climate models. The climate models don't only have to do with climate change, they also have to do with things like fisheries modeling, to kind of predict. And there's all kinds of instrumentation that needs to be better developed. It's really important that we monitor and look and observe and see how our Earth is changing. And there are a number of opportunities for computer scientists to develop new ways to do that. There's all kinds of remote sensing, like I said, from oceanography to geology to atmospheric science. So there's many opportunities to develop and have projects that interface with climate change.
And if I can just touch base on that as well, sensor development, a lot of observation of our Earth. We have to put sensors out there, right? So you need specialized sensors to, go in a certain place or to measure, tilt in a volcano or something like that. One of my classmates in my master's works as a support engineer on research cruises. So anytime we need to get this data, and he says, all right, let me build this device to get this data. So there's always kind of support engineers as well for research.
And I think you've identified there's a lot of crossover. I'm currently working with the College of Engineering. If students there decide they don't want to do engineering anymore, we're trying to get them over to SOEST. So if you're trying to address real world, large scale environmental problems, or if you're interested in applying scientific solutions to address these problems, then SOEST could be a good fit for you.
And also don't forget that we have a graduate program in ocean research engineering. And so while you might start off in engineering as an undergrad, you could, for instance, join the Miley mentoring program and then get connected with faculty in ORE and learn about those programs and then do research as an undergrad in those kinds of graduate programs.
That's what I did. I started in civil engineering and went to ocean engineering for my master's.
Awesome. And I went ahead and added the Hawaii Space Flight Laboratory in the chat, a link to their information if anybody's interested. They're also within SOEST. Okay, great. Shek has a question in terms of does Hawaii have any caving team or experience? He's gone caving before and he thinks exploring the underworld is very interesting. So do we have anything here in Hawaii or within SOEST, anybody that works with that specifically or might be able to work with that?
I think it scares me to death. I think you're brave to go down in a cave, but I'm sure that, there are a lot of folks that are looking at that. I don't know if we think of caving as popular as in Hawaii as it is in some places on the mainland, but one of the things that I wanted to add, and I'll talk a little bit later, maybe to end this thing, but is that there are a lot of national programs here as well. So one of the things that you should know is that if you get on this pathway that leads to the geosciences, you have a lot of opportunities nationally as well. There's a lot of government labs. There's a lot of schools all over the country that are doing a lot of this kind of work. So probably one of the first things you do once you decide that that's really your passion and you want to be in cave research, we find someone that puts you in touch with exactly the program that would fit you. Maybe it's a summer program, maybe it's somewhere you want to go and get a degree from. But those are the kind of things that we can do once you get on this pathway. Once you meet the counselors and you meet the instructors and you meet the faculty up at the university, the doors will open up to almost any career you'd want and can imagine.
And I think Scott mentioned something here to Ibrahim, or not, I'm sorry, was it Scott? Yeah, there is or was a Hawaii Speleological Society, but he hasn't been in contact with them. Maybe you can, I'm assuming Speleological Society is probably for cave spelunking or something.
That's what that is called. It's speleology. They used to be very active.
Okay.
And I honestly, I don't know what they're up to anymore. It's been 20 years since I was in contact with them.
Yeah, okay. Maybe you might want to look into that, Shek. Maybe there's possibly something there. Maybe they still have a chapter or something here in Hawaii. And an interesting fact from Rosie that SOEST is ranked 13 in the world for geosciences, and that's ahead of MIT. And that's actually something to be proud of, I would say, because MIT is usually ahead of the curve when it comes to a lot of these types of programs. We also have a question. Are the recordings going to be posted anywhere? Yes, I believe so. I think they'll be on the KCC STEM website. I have to double check, but we'll keep everybody notified in terms of that.
I also wanted to make a comment, if I could, on terms of workforce. One area that we all in STEM fields don't spend enough time talking about is the opportunities that you have as a teacher, as a potential teacher in high school and in middle school and so on in these areas. The national teacher organizations now have all adopted earth science as a big area that's going to be brought into the K-12 systems. And we are woefully misrepresented in our K-12 systems with faculty who know enough to be able to teach these courses and develop and design this curriculum. So it's really going to become very, very important. It's clear nationally that we put this in the K-12 education system, earth sciences, but we need faculty to teach that in the high schools. And if you've thought about that at all, that's a great area and a great job that is, all over the world and is needed everywhere. And it might be something to think about as well, because earth science is going to become very, very important in the K-12 systems in the country. And
to follow up on that, in terms of getting students prepared for science, a lot of times the place to do that is at the high school or even at the middle school level. And very few middle school teachers have any kind of familiarity or background with science. And so if you are thinking about going into teaching, having a science background can give you sort of a leg up in getting jobs because you're a little more in demand.
There was a question about physics majors that I'd love to address. So
yes,
is that okay?
Yeah, go ahead, Gary. Yeah.
So if you're interested in physics and you want a thriving career and where you can use your physics to do lots of things, then a minor, for example, in geoscience with a physics major makes a very attractive package for future career in that, especially for graduate school, for example.
Great. Again, it's like Don and Jacob. A lot of these fields that you actually end up, regardless of what field you get into, there's a lot of application that you can apply or implement in terms of like the fields that SOEST covers. So there's a lot of things to be done there. We're going to go ahead and pass it to Dr. John Rand. He's the professor at Kapiʻolani Community College and the principal investigator for the GeoPath Impacts grant that's funded by the NSF here. So he's going to grace us with a closing statement and a few thoughts, and we'll close out the event with that. So Dr. Rand, if you want to go ahead and take it over.
Thank you, John. Wow, this is fantastic and lots of information that was absolutely vital for students. I want to thank Jonathan, and who works for the GeoPath program, as well as Calais at KCC for hosting the program and putting this together. These are amazing when we do these sort of webinars that turn into conferences, which are fantastic. And you get a lot more information than you think you're going to, even though we're not face-to-face. So I appreciate the work that you all do. All of the speakers as well. Thank you so much for being a part of this. These are your actual faculty that are going to be teaching this natural hazards class. So I think it sounds very exciting. I really think I wish I could go back to school maybe and take some of these courses, because this is really exciting stuff. This is stuff I wish they taught rather than straight physics or straight chemistry. It would have been fun to have some of these other courses to look at. So you're in a great place if you want to do that. I wanted to mention real quickly that there are scholarships available for students who are sort of decided to jump into the pathways. So again, as our counselors mentioned, you can get into the ASNS pathway, the Associate of Science and Natural Sciences, through the community colleges and work your way to a degree at SOEST. And there are scholarships available right now as we speak at all of our campuses. So Leeward has some funding, and that we have some money for peer mentoring and so on, and for students that might want to work in this area or go to school in this area at KCC. And then we also can fund students at Manoa through our Miley mentoring program or other programs that we have. So please stay tuned to all these folks who you've seen today, and make sure you got their emails handy. If you want to seek out funding for college, you should look for doing that, okay? Once you get to a certain level, we really want to help you stay on the path. I also wanted to, I wanted to mention the bit about teachers, because I think that's really important. It's an area that I've been working in, and it's going to become a crisis situation in Hawaii if we don't have any earth science teachers. And so this is an area that you can get into and start off a really good career. It's one that's very, very rewarding. So I wanted to mention that as well. So thank you, everyone. I know it's late in the day. I appreciate it. Stay tuned for more information from the GeoPath program and the geosciences folks here at the University of Hawaii. And please reach out to these folks. They're the experts in the field, not just in Hawaii, but in the field. So please pay attention to what they have to say, because they can really help you in your quest for a degree and a career. So thank you, everyone.
And with that, thank you, Dr. Rand. And with that, that concludes the Spring 2021 KCC STEM SOEST Pāʻina. Mahalo, everybody, for joining us. We really appreciate you guys. We hope that you took something away from this. Thank you again to all my presenters, and thank you for all the help I've had coordinating this, specifically Kalei, Josh, and Leanne over at KCC STEM. Thank you, everybody. We hope you took something away, and mahalo.